An assertion by Stephen Pedling suggests that the universe we observe is merely a fragment of a larger multiverse. In this greater reality, there could be countless versions of ourselves existing in parallel universes. The James Webb Space Telescope has now uncovered compelling evidence for a mirror universe, detecting massive structures that appear more complex than the known universe. These structures may originate from a parallel existence where the fundamental forces resemble those in our own universe. The implications of these findings stretch the boundaries of our understanding, challenging conventional perspectives. Could we be witnessing the existence of alternate realities? And if so, what might they reveal? Such questions propel us to the frontier of science, potentially redefining our grasp of reality. The story begins in late summer 2022 when NASA released the first images captured by the James Webb Space Telescope. For the general public, these images displayed stunning celestial features, but experts noticed something extraordinary: exquisitely detailed structures, younger and more refined galaxies, and patterns that stood out. Particularly striking were the foreground galaxies, which appeared in hues ranging from orange to rosy, with diffused and dimmed light. Despite their faint appearance, the James Webb Telescope, equipped with advanced infrared technology, could analyze even the faintest traces of light to uncover their origins and characteristics. The telescope's capabilities extend far beyond those of its predecessor, the Hubble Space Telescope, allowing it to measure light that has traveled billions of years through space. Using redshift, the stretching of light waves as the universe expands, scientists can estimate the age and distance of celestial objects. A remarkable discovery was a galaxy with a redshift value, Z, of 13, indicating that the light we observe from it is 13.5 billion years old. This discovery highlights a fundamental principle of astronomy. When we observe distant objects, we are effectively looking back in time. For example, the light from Alpha Centauri, our nearest star system, takes 4.3 years to reach Earth. By examining light that has traveled for billions of years, the James Webb Telescope enables us to glimpse the early universe. The implications of these findings are profound. If the Big Bang occurred approximately 13.8 billion years ago, we should be able to observe the first stars and galaxies that formed around 500 million years after this event. However, the telescope has identified galaxies, such as GLASS Z13, that existed just 300 million years after the Big Bang, and another, Macy's galaxy, dating back even earlier. These galaxies are not primitive. Instead, they appear to be highly developed, massive systems. This raises a pivotal question. How could such complex structures exist so soon after the Big Bang? The formation of galaxies typically requires billions of years, yet these early objects seem to defy conventional models of cosmic evolution. One galaxy, identified with a redshift value exceeding 28, may be among the earliest and most distant systems ever observed, challenging existing theories. These discoveries suggest that our universe may not be as singular as we once believed. Instead, they hint at the possibility of alternate timelines or a multiverse where conditions and laws may differ. Such revelations force scientists to rethink the origins and structure of the cosmos, opening the door to revolutionary ideas about the nature of reality. As research progresses, we may uncover evidence that reshapes our understanding of the universe and its place within a broader multiversal framework. Following the colossal impact and near the boundary of the mirror universe raises a profound question. Could our universe exist as part of an hourglass-like structure? In this perspective, the mirrored universe would represent the other side of this cosmic hourglass. Somewhere, a point of exchange or connection might exist where these two universes meet and interact. In the vast expanse of the universe, this meeting point may not be confined to a single location. It could occur in specific places or moments. By visualizing this through the lens of the James Webb Telescope, one might imagine traveling back through the hourglass's narrow passage to the other side, revealing entirely new realms of understanding. One intriguing theory supporting this idea involves the chime-ringer hypothesis, a mental and quantum exploration of existence. This theory suggests that nothing in the universe has a fixed form until observed, existing instead in a state of suspended ambiguity. It proposes that the very fabric of reality can manifest as waves or probabilities, becoming concrete only upon interaction. At the hypothesized mirror boundary, this interaction between universes might become tangible. The chime-ringer hypothesis further expands to suggest a multiverse, a collection of infinite universes, where you and I might simultaneously exist in countless realities. While we remain unaware of these parallel existences, advancements in observational tools like the James Webb Telescope push the boundaries of our comprehension, unveiling previously unimaginable possibilities. These discoveries compel us to rethink our position in the cosmos and consider the enormity of what lies beyond our current understanding. The idea of a multiverse challenges traditional notions of existence and expands the frontier of scientific inquiry. Each discovery from the James Webb Telescope and similar endeavors not only tests existing theories but also opens the door to entirely new domains of possibility. This pursuit reveals that our understanding of the universe is but a fragment of the greater reality, urging us to embrace the mystery and wonder of what lies ahead. One of the groundbreaking observations made by the James Webb Telescope includes the detection of Glass C13, a celestial object with a remarkably high redshift value. Shortly after its discovery, another distant object with an even higher redshift was confirmed. These findings suggest the presence of some of the earliest and most distant galaxies ever observed, dating back to just a few 100 million years after the Big Bang. While these discoveries await confirmation by independent research teams, they challenge our previous understanding of cosmic evolution. John Mather, the project leader of the James Webb Telescope, remains optimistic. He argues that these revelations do not contradict the Big Bang theory but rather demonstrate that stars and galaxies formed much faster than previously believed. However, not all scientists share this view. Some propose alternative theories, such as Roger Penrose's hypothesis of a dark universe, suggesting that our universe emerged directly from a prior one, carrying remnants of ancient structures. This theory offers an explanation for the presence of old cosmic features that defy conventional understanding. Additional hypotheses, such as Brad's interconnected universe model, propose that the Big Bang occurred 26.7 billion years ago, or potentially even earlier, challenging current estimates. Others suggest phenomena like intense starbursts in the early universe, which could account for the rapid formation of massive celestial bodies. Despite these competing theories, the James Webb Telescope continues to uncover astonishing details. A year after its initial images, a second image confirmed the existence of phenomena previously thought impossible under conventional physics. For example, behind the Pandora cluster, a newly discovered entity was revealed, inconsistent with its size and location within the youthful universe. These anomalies push scientists to develop new models and explore innovative theories to explain these findings. As researchers delve deeper into the mysteries of existence, the universe increasingly appears as a dynamic and interconnected entity. With each discovery, our understanding grows, but so too does our realization of how little we know. Amidst this uncertainty lies a profound sense of wonder and excitement, as humanity embarks on a journey to uncover the secrets of the cosmos, and, ultimately, the mysteries of our own existence. Disclosures about the universe have sparked discussions about their implications and whether they should be objectively categorized. Recent findings, confirmed through advanced testing by the James Webb Space Telescope, JWST, suggest that the formation of stars and galaxies occurred much faster than previously believed. John Mather, the principal investigator and a key figure in the development of the JWST, remains optimistic about these revelations. Although these findings don't confirm a massive cosmic explosion, they do indicate a rapid evolution of galaxies and stars in ways that challenge existing theories. An emerging narrative suggests that some researchers are rethinking the validity of the Big Bang theory. Advanced models and theoretical frameworks propose alternatives to this foundational concept. For instance, Canadian scientist Braden Frame posits that the universe might be far older than currently estimated, placing its origins at around 26.7 billion years, or potentially even 40 billion years, using modified Newtonian dynamics and the theory of light fatigue proposed by Swiss astrophysicist Fritz Zwicky. One explanation for the anomalies observed in the JWST data involves periods of intense star formation, known as starbursts in the early universe. These events could have produced an unusually high number of stars in a short span. However, this theory struggles to account for the large-scale structures of the universe. British physicist Roger Penrose's conformal cyclic cosmology suggests that our universe emerged from a prior one, carrying remnants of its predecessor. This idea aligns with the possibility that ancient structures, observed in recent JWST images, might originate from an earlier cosmic era. Despite their potential, these theories share a common limitation. While they partially explain new discoveries, they fall short of providing a complete picture. The JWST's subsequent deep-field images have only deepened the mystery. These images revealed ancient galaxies and previously unidentified structures, features so massive and well-formed that they defy existing models of early cosmic development. For instance, an unexpected structure behind the Pandora cluster exhibits properties incompatible with what should have been possible in the young universe. Such findings highlight the limitations of our current understanding of quantum mechanics and astrophysics. Theories like string theory, which suggest the existence of a multiverse, are gaining traction as potential explanations for these observations. If the multiverse hypothesis holds true, it could help reconcile the apparent discrepancies between the behaviors of the smallest particles and the largest cosmic structures. Some researchers argue that the inability to observe certain phenomena stems from inherent limitations in our perception and tools rather than from flaws in the theories themselves. In summary, the groundbreaking images and data from the James Webb Space Telescope are challenging the foundations of cosmology. As physicists and astronomers scramble for new explanations, the stage is set for revolutionary theories that may redefine our understanding of the universe and its origins.